Oh, hello guys. Welcome back to my channel, guys. Last night I did a video about interpretation of box and whisker. So I felt that now this is not fair. So I had to come back now to take you through how do we actually draw the box and whisker diagram. So this video is about summarizing the data now, right? My focus area of this video now is going to be about summarizing the data. I'm going to focus now on the measure of central tendency and the measure of spread, right? But now, before I start going to the measures, there is some critical information that I want to bridge before I go to the measures, right? So let's quickly go to that information that I want to talk about it actually. So right, the information that I want to talk about, that I want to emphasize here, is type of data. Right, this information, guys, is very crucial because I find it that other other keys, they don't find it very well, right? So I have to brush it now. We only have two types of data, right? So mainly the first one, we talk about the categorical data. Then the second one here, we talk about the numerical data. Alright, I'll just explain now what kind of a data we're talking about when we talk about the categorical data. Right, guys, when we talk about the categorical data, we talk about a grouped sample, right? It means the data that is given to us is being grouped. It can be grouped in terms of color, it can be grouped in terms of models, it can be grouped in terms of flavors. Let me give an example. We can be given a data about flowers, right? So those flowers now, when they give us, they say red flowers they're 4, white flowers that is, yellow flowers that is. So it means now the data that is given is categorical. So it is the flowers. So those flowers have been grouped. So it means our sample now is being grouped. So we call that data a categorical because the sample is being grouped. Right. When we talk about a numerical data here, we are strictly talking about two types here, but the types here we're talking about, they are not types of data, they are types of numerical data. So when we talk about the numerical data here, we talk about the discrete data, and continuous data. What is happening now? Continuous data now. Right, let me start with the discrete. A discrete data, it is a data that can be counted. We know that every time when we talk about a data that can be counted, we talk about discrete data. Let me give an example. Here is Sir got into class. He just count the learners that are in class. He wants to take the register for the day. He wants to know how many learners are present. So what does he do? He counts. The moment he counts, it means the person is going to have a discrete data, right? Now, when we talk about the continuous data now, it is a data that is measurable. It can be measured, right? It means now the continuous data now can be measured, right? That is the difference between the two. The discrete data, it can be counted, and the continuous data, it can be measured. That is how simple I make this these two to be simple, right? Now let's move on. I want us now that is the crucial information that I wanted to iron out before we go to summarize our data now. Right. Normally when we summarize our data here, we look at two measures. So the first measure here that we're going to focus on, the measure of central tendency. Measure of central tendency, right? So in measure of central tendency, we talk about three things, right? We talk about three things. We talk about your favorite. I know this one's now. When you talk about Nestle learners now, when they think about data handling now, what comes to their mind is mean, mode, median. But now, here we summarize them. When we summarize them, when you talk about the measure of central tendency, we talk about mean, mode. We talk about the median. These are the only measure of central tendency that we have in data handling, right? Right, what is the mean? That is the first thing that we're going to deal with, the first terminology, right? So, mean here we talk about what? Is the average. Is the average of the data. Every time in data handling, when you talk about the average, you're talking about the mean. When you talk about the mean, we talk about the average. Right, so let me give an example. So one now can say, okay, since we say we talk about the average, then how do we calculate the average? Because the mean, in order for you to get the mean of the data, you've got to calculate. You have to calculate it. You cannot just identify it from your data. You have to calculate it. So how do we calculate this mean? We say the mean is equal to sum of all values. Sum of all values divided by total number of values divided by total number of values. So let me give an example. Let me use a different pen. Okay, we have 1 here, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, we have 10. Right, therefore now this is a data that is given to us. So now we want to know what is the average of this data, or what is the mean of this data. So what do? We have to sum all the values. These are our values, so let's sum them. So when we sum them, it's going to be 1 plus 2 plus 3 plus 4 plus 5, this is 4, plus 5 plus 6 plus 7 plus 8 plus 9 plus 9 plus 8, okay, plus 10. Right, then we divide by what? we're going to divide by the total number of values. How many values are here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 values. Therefore, we're gonna say when we add all of these numbers now, we're gonna get 55 over 10, right? So which gives us 5,5. So it means the average of this data is 5,5, right? Now let's move on. We move on to the next one. So in the next measure of central tendency, there we talk about the mode. So what is the mode? The mode is the number that appears the most in our data set. Let me give you an example. So I'm gonna say 1, 5, 7, 9, 10, 1, 2, 6, 4, 3, 2, 6, 10, 1. Now here's our data now. So we're going to check the number that appears the most in this data so that we know that this number is the mode. We are not saying the numbers, we say a number that appears the most, right? So when you look at this data, we can see that we have 1 here, we have 1 here, we have 1 here. Therefore in this data 1 appears 3 times, right? But we also have, let me see, we also have 2, we also have 2 here. So 2, it is appearing 2 times. Let's observe another number here. I can see 6 here, and I can also see 6 again here. So 6 is appearing twice. So now let's take a conclusion now. So when we take a conclusion, now we compare this. Which number here appears the most? 6 is appearing twice, 2 is appearing twice, but 1 is appearing 3 times. Therefore 1 is our mode in this case, because 1, it is appearing more than other values. Right, now I'm going to give you another example now. Okay, let me do this. Let me remove this number here. Here is our data now. Let me remove this. Here is our data now. Which number now is going to be our mode? Because now when we count, we can see 1, we can see 1. That means 1 is appearing twice. So in this case, we don't have mode, we have modes, because we cannot take a conclusion here. So we're going to say our mode in this case is 1, 2, and 6, because now all of these numbers, they are appearing 2 times each. So we cannot take a conclusion that is 1, is 2, or is 6. So all of them, we take them that these are our modes. We leave them. Right. We go to the next measure of central tendency here. We're going to talk about the median. We're going to talk about the median. Right, let me see the black one. Alright, so when we talk about the median here, we talk about the methyl number. Not methyl numbers, we talk about a methyl number. Right. There's the median. Right. So before I'm going to give an example, or we're going to do something, I want to tell you how I make it simple to get the median, right? So the first thing that I do, I have rules. I only have 2 rules to identify the median. Rule number 1, you must arrange. When you arrange your data, you can arrange it in 2 ways. It's either you arrange it in ascending or you arrange your data in descending order. ascending or descending, right? What are we talking about when you talk about the ascending order? It means in ascending order now, we talk about, we arrange our data from the minimum number to our maximum number, right? So when you talk about descending, we talk about maximum number to minimum number. We arrange our data from the smallest, from the biggest number to the smallest number, right? So in ascending, we start from the smallest number to the biggest number, right? So after you have arranged your data, rule number 2, you must tell if your data is even or your data is odd. After counting your values, how many values are there? You find that you count 10 numbers. Is 10 odd or even, right? That's the question that you have to ask yourself, right? So let me explain, how do we know that a number is odd or even? Now, we're going to take all our natural numbers. I'm giving an example about 1 to 10. Right? So, those numbers, the natural numbers, we have the numbers that are odd, we have numbers that are even. Let me tell you when is a number an odd. Right? Right. So now you take your natural number, you divide it by 2. If you get a decimal, that means that number that you have divided by 2, it becomes your odd number. Now if you take your natural number and you divide it by 2, you get a natural number. That means now we talk about a data that is even. So if your data is even, what does it mean? It means they are two numbers in the middle. I am not saying there are two middle numbers. I'm saying there are two numbers in the middle. So if your data is odd, it means there is one number there's one number in the middle. There is one number in the middle, right? You arrange your data. Now after that, rule number 2, you now check, is your data even or odd? If your data is even, it means there are two numbers in the middle. If your data is odd, it means there is one number in the middle, right? Now we're going to move. Let's move forward now. I'm going to give an example with this data now, which has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Let me remove that. Yeah. 7, right? Even though I'm not getting this 7 correct. Right, we want to find a middle number here, and then the other thing that I have to mention there is that the middle number divides our data into two equal parts. So now this data already it is arranged, so we have to go to rule number 2. Let's check, is this data an odd or even, right? So when we count our numbers, it's going to be 1 2 3, okay, 1 2 3 4 5 6 7 8 9 10, right? So it means now 10 is 10 an odd or even. So the answer is, when we divide 10 by 2 we get a natural number, which is 5. That means here we talk about the even number. So what does it mean if the data is even? It means there are two numbers in the middle, right? So let's check what are those numbers. I'm going to do this. This is how I'm going to know our middle, the numbers that are in the middle. I count 1 2, then that side I also counted 2, 3 3 4 4. So the numbers that are in the middle are here, right? Now listen to me, what I'm going to say. Between these two numbers there is no middle number here. Between 5 and 6 there is no number that represents a middle number, but the middle number is between 5 and 6. Therefore 6 and 6 and 5 will help us to determine our middle number. So our middle number is here, and then like I said the middle number divide our data into two equal parts, right? So when we calculate the median here, this is what we're going to do. We must calculate the mean of those two numbers. We have to calculate the average of those two numbers. The two numbers we talk about, 5 plus 6. So how many numbers are here? They are 2. So this is equals to 11 divided by 2, which is equals to 5,5. 5,5. That means now the middle number here is 5,5. Let me write it here on top. Let me write it with the red pen. That means our middle number here is 5,5. And here guys, we don't round off, because the moment you round off now, you are changing now. Your middle number now is no longer going to be 5,5. It's going to be another number. So here we don't round off. We remain with 5,5, which divide our data into two equal parts. Right. Let me give another example with this data. Remember the first one that we dealt with, it was having an even number, 6 7 8 9 10 11, right? 11. So when you look at this data, it has odd number. What does it mean? We go back, we check here. Odd number, it means there is one number in the middle. Right, let's check, let's count them. I'm going to count 1 2 3, 1 2 3, then I say 4 4 5 5. So the middle number here, we don't have to calculate our middle number here. Our middle number is 6. And listen to what I'm going to talk about, because I'm going to talk about these two examples of data now. This middle number, do you see this one is I'm even rubbing it out, it's no longer now visible. Okay, here we have 5, then here is 6, right? Let me use black. Right, let me just draw this. The position of this middle number is center. It is here, meaning it does not belong to the left, it does not belong to the right. The position of this number is center. If you look at this 5,5, the position of this number is the center. It doesn't belong to the left or it doesn't belong to the right. The position of this number is center. So when you look on the left, we are having 5 numbers. Therefore, when we look on the right, it is a must that we have 5 numbers. So let's confirm. It's 1, 2, 3, 4, 5. Therefore, the numbers on the left, they are equal to the numbers on the right. So even here, when you check, we have 1 up to 5. Here we have 6 up to 10. So 5 numbers, 5 numbers. So the middle numbers here, the middle number here, it divides our data into 2 equal parts, right? So it means now, out of 100% of the data that we have, now the right hand side has 50% and the left hand side has 50%, right? So that is how the Q2 divide our data in, right? I'm not done with this because we're still going to engage with this one when we go forward, right? Now we're done with the measure of central tendency. Now we're going to do a measure of spread. Measure of spread. Right, in measure of spread, we focus on range. Let me just do this one in first. So when we talk about the range, we talk about maximum number or the highest number minus the minimum number. Let me give an example with the data that we are working with. So if we look at this data, which number represents the maximum number? If we say 10 is the maximum number, it means there must never be any number after 10, right? But when we check, after 10 there is 11. But now after 11, is there another value there? We no longer have any value. That means in this data set, our maximum value is 11. Now, is there any number that is lower than 1 here? We don't have. Therefore, 1 is our minimum value. So if we want the range of the data, we're going to say range is equals to 11 minus 1. Therefore, our range is 10 for that data, right? Now, the second measure of spread, okay, we talk about quartiles. We talk about quartiles. Let me do this. Guys, when we talk about the quartiles, we talk about middle numbers. You remember that side, that time I said middle number. Those numbers that are in the middle, the two numbers that you will find in the middle, they are not middle numbers. But here when you talk about, because quartiles, we don't have only one quartile, we have 3 quartiles actually. So all of those quartiles, they are middle numbers. They are middle numbers. They are middle numbers. They are middle numbers. So the quartiles that we talk about here, we talk about quartile 1, we talk about quartile 2, we talk about quartile 3. Right. In this case, in most cases, when we talk about, when we approach a question, we start at the bottom, going to the top, or we start at the top, going to the bottom. But here is a different story. We start in the middle. The middle one is the one that is going to give us a direction. We must start by understanding this. If we understand quartile 2, then we will be able to understand quartile 1 and quartile 3. Okay? Right. When we talk about quartile 2, we are simply talking about the median. The same median here. If I want to check which number here represents quartile 2, I will still say 6 is quartile number 2 because it's our median. Right? So, does it say, let's go to our explanation. We say quartiles are middle numbers. Is a median a middle number? That means now we are correct. Now remember, the middle number now has divided our data into two equal part, which is 50%, 50%, right? So now, let's talk about quartile 1. I'm still going to use the same data. So when we talk about, let me go back. Okay. Remember we said now this is 50%, this is 50%, right? So we have the first 50% and we have the second 50%, right? Now when you talk about quartile 1, is the middle number in the first 50%. Is the remember I said quartiles are middle numbers. So let's go to that data. Okay, let me do this. Let me write it here. Our data was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then we said 6 is quartile number 2, right? We said 6 is quartile number 2, right? So this is 50%, this is 50%. So we have the first 50% and the second 50%. So our first 50% start from 1 up until 5. Then our second 50% start from 7 up until 11, right? So we say quartile 1 is the middle number in the first 50%. So that means we must look for a middle number between 1 and 5, the numbers in between, right? So if we check is 1, we're gonna say 1, 1, 2, 2. Then the middle number is 3 here. That means our middle number here is 3. So 3 is our quartile number 2. Remember 6 here is quartile number 2. Then let's talk about quartile number 3. Let me write quartile 3 here. Quartile 3 is the middle number in the second 50%. So let's check. This is our first 50% we talked about. It only talks about quartile 1. So the second 50% is here. So it's only going to talk about quartile number 3. So we're going to look for a middle number between 7 and 11, right? So our middle number here is going to be 9, because if you check on the left you have 2 numbers, on the right we have 2 numbers. Therefore 9 represents our quartile number 3. Oh, why do I write 2 now? It represents quartile 3. See now, even this 3 now, it doesn't want to be there, you know. It is representing quartile 3. So that is how our quartiles work. So if you check everywhere where you see a quartile, it is representing a middle number, right? Now we start here. On these percentages now, we say quartile 2 is 50% of the data. Then quartile 1, we're going to say is 25%. Why is it 25? Because now this is the 50%. Now it is divided into 2. Then it's 25. Ne? But now here's another story. Now quartile 2, we are here. Then this 50% is going to be divided into 2. Then we're going to say it's 25, 25. Then we're going to say the 25% of these 2 numbers plus 25%. Then they will leave us at this point, which is going to be 75%. Then now if you check, okay, here I was talking about the quartiles only, but I wanted to do something here. Let me leave it. I will do it later on, but not just far, but after doing the interquartile range. So let me quickly do the interquartile range and then explain what I wanted to do. I wanted to do something massively here, but I remember that I will skip this thing. Now, when we talk about the interquartile range now, we talk about, look at this, range of quartiles. How many quartiles do we have? We have only 3 quartiles, which is quartile 1, quartile 2, and quartile 3. So here we're going to employ the concept of range. When you talk about range, we talk about the maximum value minus the minimum value. So here let's check, what is the maximum quartile? Is quartile number 3 minus the lowest quartile, which is quartile number 1. Then this is how we calculate the interquartile range. Then now let's see how much is our interquartile range. Is going to be 9 minus 3. That means our interquartile range now is 6. There we have it. There we have it. There we have the interquartile range. Now we are done. Now I will come to that. Let me go to it now. Now we are going to talk about 5 number summary. Right, guys. Here, remember our main idea is to draw the box and whisker diagram, because that is why my main purpose of doing this video is to do the box and whisker. So the 5 number summary here, we talk about the 5 numbers in our data. You see, a data can have million numbers, but 1, 2, 3, 4, 5. We need only 5 numbers. Which are those numbers? We need the minimum number. We need quartile 1. We need quartile 2. We need quartile 3. And we need the maximum number. Here it means we talk about a mixture of range plus quartiles. Then they give us a 5 number summary. So let's go back to the previous one. This is what I wanted to touch. So if you look at this, what is your highest number? Is 11. That means 11 is representing our maximum number. Then if you check now, what is the lowest number? Is 1. That means 1 is our minimum number. Here we have summarized our data. Our data is summarized. In this data we can see the smallest number, we can see the middle number, we can see the middle number of the first 50%, which is Q1. We can see the middle number in the second 50%, which is Q3. We can also see our maximum number. Right. Getting to an end. It means our minimum number is 1, quartile 1, 3, quartile 2, it was 6, then quartile 3 is 9, then our maximum number is 11. Right. Now we're going to use the 5 number summary to draw our box and whisker diagram now. Box and whisker diagram. Right. How do we draw it? We are going to employ our 5 number summary. Look at how I'm going to draw it. I'm just going to draw a general one. I'm not going to use a scale here. So it's 1, 2, 3, 4, 5. Right? Then we're going to draw a line here, and a line here, and a line here, and a line here. Right? So in the 5 number summary, if you check, our first number here is the minimum. So this is minimum, Q1, Q2, Q3, and maxima. So I want to show you again how we can do our 5 number summary. We can do this 1, 2, 3, 4, 5. I want to show you that things doesn't change according to how this thing is standing. We can also we can still do the box and whisker to stand vertical. So we know that if this one, we're going to check the scale, so this one can be the minimum. If this one is the minimum, this is Q1, this is Q2, this is Q3, and this is our maximum number. So if they gave you a 5-number summary, remember now, if they give you the box and whisker plot, it means the data have been summarized for you already. So what you need to do to interpret all? So the number that you see on here, it means is your maximum number. Your maximum number cannot be here. The number that you see that is on this line, it means it's your middle number. Right? So in terms of percentage, this is 50%, this is 25%, this is 1%, this is 75%, and this is 100%. Right? So in a data, this is how we interpret it. Here at quartile number 2, I'm going to give you the example with the marks. Let's say this is a scale representing the marks: 60, 40, 10, 70, and 80. Now, these marks, these are the marks of learners. Ne? So, if you see 60 here, we look on top. It is aligned with which quartile? It is aligned with quartile 2. And what does it mean? It means that 50% of the whole class got less than 60 marks, whereas 50% of the class again got more than 60%. Then let me explain this one again. Here it means that 25% of the whole class got less than 40, whereas 75, how do we get 75? We say 25 minus 100. We're going to see that now from here up until here we have 75%. So is 25% less than 40 and 75% more than 40. Then let's come here on 70 marks. It means 75% of the class got less than 70 marks, whereas 25% of the whole class got above 70 marks. I hope it makes sense. Go back to it, just listen to me carefully, and then you will hear exactly what I say. That is how we interpret the box and whisker plot, and that is how we draw it using the 5-number summary. I just summarized the data and I just showed you how to summarize the data now. So this brings us to the end of the video. So I say thank you guys, see you soon. I love you all. Please make sure that you subscribe to my YouTube channel and comment on whatever that you want to know. If you want me to focus on a certain chapter, comment there, tell me which chapter I must do, and then I will do it for you. Thank you.